Hi, I am Atanu. In this tutorial video, you learn all about the quadrilaterals, its properties and theorems. First, we learn all component related to quadrilaterals. It is the polygon with the four-sided, two-dimensional or the plane figure. So let's take one example. Here, A, B, C, D is a quadrilaterals. These are the sides. So sides are AB, BC, CD and DA. And AB, BC, these sides are called consecutive or the adjacent side. So example of consecutive or adjacent sides are AB, BC, or you can say BC, CD or CD, DA. So what are those opposite sides? Opposite sides are AB, DC and BC, BD. A, B, C, D are four corners or vertices. Angle A, angle B, angle C, angle D, all are the interior angle, or simply you can say this is the angle of the quadrilaterals. So what are the pair of the consecutive angle? Next we learn the theorem angle sum property. Here if you consider ABCD as a example of the quadrilaterals, sum of this interior angle A plus B plus C plus D is equal to 360 degree. How you can prove that? First we draw a one diagonal. What we get, two triangles are there. So sum of this interior angle of this triangle ABC from the angle sum property of the triangle is what? Is equal to 180 degree. And from this triangle ACD we get 4, 5 and 6 is equal to 180 degree. Now if we sum together we get 1 plus 6 plus 2 plus 3 plus 4 plus 5. So this value equivalent to what? 360 degree. And 1 and 6 is angle A, and 2 is equal to B, 3 and 4 angle C, and 5 is angle D. Next we learn the special type of the quadrilaterals. First is parallelogram. Here the opposite sides are parallel. A, B, C, D is a parallelogram. So we can say AB parallel to DC and AD parallel to BC. And also opposite sides are equal. Clear? Next is rectangle. Here all corners are 90 degree. CD, and also opposite sides are equal. So we can say that if the parallelogram all interior angles are 90 degree, then it's become the rectangle. And when the all sides of the rectangles are equal, then it's become the square. That's all 90 degree, and all sides here are equal. And here it is trapezium. Only one sides, only one pair of opposite sides are parallel. ABCD is a trapezium. Then we can say AB parallel to DC. And when these other two non-parallel sides are equal of the trapezium, then we can say this is a isosceles trapeziums. And this is the rhombus. When this square we tilt, means we apply force this oppository side, then it's become a rhombus. So all sides are, and this is also a parallelogram, but all sides are. When it become kites, if the two adjacent sides are equal, then we can say it is the kite. We know all detail some theorem and properties of some special figure. First, we know the one theorem related to the parallelogram. Diagonals of the parallelogram bisect each other. Before that, we should know difference between the theorem and properties. The property is something that need no proof. So property is considered with the for this. For example, the opposite sides are parallel to each other and equal to each other for the parallelogram. These are the properties. Okay. So properties come first, and sometimes that need no proof. Clear? Next, we derive the theorem. Clear? Based on the properties. So here we prove based on the property one theorem, that is diagonals of the parallelogram bisect each other. Let's consider a parallelogram ABCD, and here you can say AB parallel to CD, and also AB is equal to DC. So in between triangle OAB and triangle OCD, these two angles are alternate interior angle because DC and AB are parallel and DB is transversal. Angle OBA is equal to angle ODC, and also this angle equivalent to this angle because DC and AB are the parallel and AC is transversal. So you can say that angle OAB is equal to angle OCD, and these opposite sides are equal. CD. So we can say OAB congruent to triangle OCD. Angle side angle congruency. So you can say that OA is equal to OC and OB is equal to OD. CPCT, corresponding parts of congruence triangle. So this is proof. So this side is equal to this side and this side is equal to this side. So you can say this. AC and BD diagonals bisect at O. So what are those properties of the parallelograms? AB parallel to DC. Opposite sides are parallel to each other, or you can say AD also parallel to BC. Next is opposite sides are equal. We can say AB is equal to DC or AD is equal to BC, also equal. So this is the interior angle. Opposite angles are also equal.
Since in parallelogram opposite sides are parallel, let's example AD and BC are the parallel and AB transversal. So angle A and B are the co-interior angle, that is 180 degree. And also the diagonals of the parallelogram bisect each other, and each diagonal produce or divide the parallelogram into the two congruent triangle. So we can say that triangle ABC congruent to triangle CDA and triangle ABD congruent to triangle CDB. Now we learn minimum condition for a quadrilaterals to be a parallelogram. First theorem, if the opposite sides of the quadrilaterals are equal, then it is parallelogram.
From the SSS congruence criterion, we can say that angle ABC congruent to CD. From here, alternate interior angles with the transversal AC, so we can say that AB parallel to DC. Or also, if this angle is equal to this angle, so this is alternate interior angles and AC the transversal, so we can say AD parallel to BC. So we can prove that from the congruency and CPCD from these alternate interior angles that AB parallel to DC and you can say ED parallel to BC. So ABCD is a parallelogram. Next theory is, second condition is, if the opposite angles of a quadrilaterals are equal, then it is a parallelogram. How we can prove that? Let's consider ABCD a quadrilaterals. Here the opposite angles are equal. Okay, so let's consider this A plus angle C plus angle B plus angle D is equal to how much? 360 degree. So we know here it is given angle A is equal to angle C or angle B is equal to angle D. So we can replace the C with A, so we can write as A and D with B, and B plus B is equal to 360 degree. So from here we can write angle A plus B is equal to 180 degree. So this is co-interior angles where the AB is the transversal to the line AD and BC, and this A plus B is equal to 180 degree. This is the co-interior angle, so AD parallel to BC. Similarly, we can prove that AB parallel to DC. So these quadrilaterals become a parallelogram when the opposite angles are equal. If the diagonals of a quadrilaterals bisect each other, then it is a parallelogram. So let's take this example. ABCD is a quadrilaterals, and what is given? These diagonals are bisect at point O. So from the SAS congruency criterion, we can say that triangle AOB congruent to angle COD. Why? Now look at this. This side equivalent to this side because it bisect. this side is equal to this side, and these are opposite angle. Vertically opposite angles are equal, so side angle side. Okay. From here we can say that this angle is equal to CPCT, this angle, but these are alternate interior angle, and AC is the transversal to AB and DC, so we can say that AB parallel to DC. Similarly, we can prove that triangle BOC congruent to angle DOA. Again, it is SAS criterion. Why? These two sides are equal to these two sides, and this is vertically opposite angle. From here, the CPCT, we can say that this angle equal to this angle. So we can say that AC is the transversal to the BC and AD. So and they are equal, so we can say these angles are equal, so we can say BC parallel to AD. So from these two, AB and DC parallel, and BC AD parallel, so we can say that this is a parallelogram. If one pair of the opposite sides of a quadrilaterals are equal and parallel, then it is parallelogram. So let's take one example. ABCD is a quadrilaterals, and here it is given that AB equal to DC and AB parallel to DC. Since AB parallel to DC, so this angle equivalent to this angle, the alternate interior angles. Now if we consider triangle ABC and triangle CDA, what is common here? AB is equal to CD, and this angle CAB is equal to ACD, and also AD are the common. So from side angle side criterion, we can say that these two triangles are congruent to each other. Clear? From here we can say that this angle equivalent to this angle from CPCT. And now look at this. BC, now AC is the transversal to the BC and AD, and these are the alternate interior angles and also equal, so we can say that BC parallel to AD and AB parallel to DC given. From these two we get AB parallel to DC and AD parallel to BC, so this is a parallelogram. Now we learn the properties of a rectangle. So here the all angles are 90 degree. This is the first properties, and second properties is opposite sides are equal, that is AB is equal to DC and AD is equal to BC. Next is diagonals also are equal in length, so we can say that AC is equal to BD. Now when in a parallelogram these diagonals are equal, then it's become a rectangle. So when diagonals are equal, remember this means if ABCD is a parallelogram, then it has become a rectangle when AC is equal to BD. Clear? This is very, very important properties. Properties of square. It's follow the all rectangle property. When these four sides are equal, then it convert into the square. Clear? So we can say in the square all sides are equal in length. Now we learn the properties of the rhombus. If you squeeze or apply pressure to the corner, two corner, let's say it is AB, CD, then it's become a rhombus. So this is the diagonals. So it's follow all the properties of parallelogram, and also this all sides are equal, and diagonals AC and BD bisect each other at 90 degree. Clear? Now we learn the properties of the diagonals. So first, what is diagonals? It is the line connecting the opposite corner or indices of a polygon or the quadrilaterals. Let's take one example. A, B, C, D is a quadrilaterals, and if we connect the opposite corner, that is AC and DB are the diagonals. We have already learned other video that number of diagonals in a polygon with n sides is equal to n into n minus 3 by 2. For the quadrilaterals, the n is how many sides are there? 4. So number of diagonals is equal to, put the value n is equal to 4, we get 2. That is AC and BD in this figure. Now we learn properties of the diagonals of different quadrilaterals. First is rectangle. In this example, ABCD is a rectangle and AB and CD are the quadrilateral. In this example, ABCD is a rectangle where AC and BD are the two diagonals, and for the rectangles, the diagonals are equal and they bisect each other. So we can write as they bisect each other, and also they are equal. Next is square. For the square, here AC and BD are the two diagonals, and these are the equal in length and they bisect each other at 90 degree. So we can mention on this drawing, these all are the equally bisect and length also equal, and all this angle are also 90 degree. For the parallelogram, in this figure, the diagonals are not equal but they bisect each other. So we can mark on this diagram. Next is rhombus. In the figure rhombus, AC and BD are the two diagonals and they bisect each other at 90 degree, but they are not equal. Means diagonals are not equal. So we can mark here these two are equal These two lengths is equal to 90 degree. For the trapezium, diagonals are not equal and also not bisect. But for the isosceles trapezium, the diagonals are equal but not bisect each other. For the kite figure, the diagonals are not equal, but the longer diagonal, here this example BD, bisect the shorter diagonals AC. We can mark here, these two are equal. So you can write.
Now we learn the converse of the above property. Here we learn that for which condition of the diagonals the parallelogram becomes the other quadrilaterals. When the diagonals are equal of the parallelogram, then it is rectangle. When the diagonals are equal and intersect at right angle, then the parallelogram becomes the square. When the diagonals are perpendicular, then it's become rhombus. Next we learn the midpoint theorem. The line segment joining the midpoints of any two sides of a triangle is parallel to the third sides and equal to half of its length. So let's take one example. Here ABC is a triangle and E and F are the midpoint of AB and AC. Now if we connect the E and F, we get a line segment EF. And as per the midpoint theorem, this EF parallel to BC and EF is equal to half of BC. Next we learn the converse midpoint theorem. It states that the line drawn through the midpoints of one side of the triangle parallel to the another side meet the third side at the midpoint. So here it is, ABC is a triangle and E is the midpoint of AB, and also given that EF parallel to BC. Now this parallel EF cut the AC at the point F, which is midpoint of AC.